rolling. Please stand. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Credo in Deo, Patrem omnipotentem, Creatorem caeli et terrae, et in Iesum Christum, Filium eius unicum, Dominum nostrum, qui conceptus est de Spiritus Sancto, natus ex Maria Virgine, passus sub Pontio Pilato, crucifixus, mortus et sepultus, descendit ad infernus, tertia die resurrexit a mortuis, ascendit ad caelos, sedet ad dexteram Dei Patris omnipotentis, inde venturus est, judicare vivos et mortuos. Credo in Spiritum Sanctum, Sanctam Ecclesiam Catholicam, Sanctorum Communionem, remissionem peccatorum, canonis resurrectionem, vitam aeternam. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Okay, take out your notes, please. I want to wrap up the last notes on how to find maxima and minima.
That was so rude. That was not. I know, but I really thought of it. And it was a panic. I bet. What color?
As a reminder, the generic term for maxes and mins is extrema. An extremum is either a max or a min. So, there are 4 types of extrema. Somebody give me the first pair. It's the most generic one. Go. Yeah, max versus min. What's the second category? Tim. Local versus global. What does that mean? What's a local maximum? How's it different from a global?
It's a maximum, but it's not the highest maximum.
Right, it's a maximum in that local area, but not overall, not on the whole world. And a global max is what?
The highest point
On the whole,
yeah.
on the whole graph, correct. Local means it's just a maximum or minimum in that local area. For example, you had a graph that looks like this. This is a maximum. So is this. And so is this. A maximum is any point where it gets to the highest point and then comes back down. But only, let me see. Blaze, help me out. Local or global? The low one here is local. What about the middle one? Still local. And then this one? That's global. It's a global maximum because it's the highest point of the graph ever. Make sense? And these, let me see. Mary, take these. Max or min, first of all? Minimum. Local or global? In this particular one. Local. How about this one? Another local. Why are they not global?
Is it because it goes down for infinity?
Right, it goes down forever, so you're never going to get an overall low point. There is no absolute or global minimum on this graph. Does that make sense? What's another pair of categories? Julie, help me on that. Smooth versus non-smooth. There are a few things we learned about that. First of all, what's the generic way of telling whether something is smooth or not smooth? Hey.
Touch and you shall bleed.
Yeah, touch it and you shall bleed for non-smooth. That's a metaphor, of course. So, for example, if you had a regular old parabola, this would be called a smooth maximum. Whereas if you have something that comes to a sharp point, This would be a non-smooth maximum. Does that make sense? There's one more category, Nick.
Artificial, non-artificial.
Sort of.
Natural.
Natural versus artificial. What is the only way to get a not? I was gonna say it now. What's the only way to get an artificial maximum in? When do they show up? Anyway. Yeah.
It's truncated.
When it's truncated. That's a nice word. What does truncate mean? It's a big fancy word that means what? If somebody truncates my arm, what happens? They cut it off. Yeah. They cut it short. They cut it off or cut short. So for example, here's a regular if somebody artificially cuts off the graph, this only has one global minimum, and it's natural. This has two. Listen, please. This is a global min, and it's still natural. That's the naturally occurring one. But this is an artificial maximum. It is the highest point in that local area. It's the highest point the graph gets before it just stops. That's a maximum, and it's artificial. It's artificial because they clipped it at that point. By the way, here, smooth or non-smooth? Austin.
Non-smooth.
That is non-smooth. Because if you stab your hand on it, you're going to get pierced. Okay? Now, a couple things to note. Smooth versus non-smooth shows up a lot. Just want to highlight two things. Smooth maxes or mins all have something in common, specifically about the derivative. You may have it in their notes, or remember. All smooth maxes and mins have a derivative of what? There are only two types of derivatives where you can get a max or min. Okay. Zero. Smooth means the derivative, the first derivative, is equal to 0. When you have the first derivative equal to 0, you're going to get a smooth, if there's a max or min at all, it's going to be a smooth max or min. Non-smooth, what kind of derivative is that going to give you? Usually, yeah. Undefined. The first derivative is undefined. Okay? You may need to know that. Part of the reason you need to know that is if all I give you is the formula and say find all the x values where there are maxes and mins, and then I'll say tell me what they are. If I say, hey, I found 3 of them, x equals 1, x equals 2, x equals 3, I say, great, which is which? X equals 1, is that a max or min? Is it smooth or non-smooth? Is it natural or artificial? Is it local or is it global? So you'll have to do an analysis of the graph, or find out without the graph. And this is one of the ways to find out ahead of time. Is it smooth or non-smooth? Find out if the derivative is 0 or not. Let me give you a quick example. Yeah, I'll do this. F of x equals x cubed minus x. Go ahead and write that down. I want to find and categorize all extrema. So maxes and mins. Now, if you remember a few things from pre-calc, if you remember what basic shape this is, that might help. What degree is it, first of all? Josh? Degree 3. What basic shape is that? It's not a parabola, it's a degree 2.
Is it the swerve?
Yeah, it's a swerve type of thing. Now, it kind of depends. If it's degree 3, you might want to jot this down. It's been almost a year since we've seen this. We studied parent graphs last year. And cubics, a cubic is degree 3, has 2 possible shapes. Up, down, up, or down, up, down. This is if it's positive, this is if it's negative. So a positive cubic is up, down, up. How do I know if it's positive? Look at the height multiplier. In this case, it's a positive cubic. It's going to look like this. And if you draw the x-axis, how many times do you expect this thing to hit the x-axis? Mary? 3. And that's to be expected, because it's degree 3, it should have 3 solutions. Can anybody actually graph this monster? Start anywhere you want, brainstorm. It's not a heck of, by the way, graphing it puts y equals there. Y equals x cubed minus x. How are you supposed to graph something? I mean, we've done parabolas before. We start with the vertex, over 1 up 1, over 2 up 4, blah, blah, blah. And we did a parent graph of this way back when, but this is a weird one. It's kind of a mutant version. Looks like we're stuck. Yeah?
You can do, set it equals 0.
Set it equals 0. What will that find?
X.
More words.
Well, we can solve for x.
Solve for x. When you solve, you get things called what?
Roots.
Roots, also known as? X-intercepts, also known as? Starts on S. Solutions. And we know the fancy term, starts with a Z, 4 words. 0 of the function. 0 of the function. It makes the function equal to 0. At any rate, can somebody solve this thing? Becca, help me out. Is there anything you can do to that whatsoever? You can take out an x. There's a GCF. What's left behind?
X squared minus 1.
Okay. Is that a factor?
So it can factor out into x plus 1, x minus 1.
Very good. X plus 1, x minus 1. Difference of 2 squares. What roots do you get out of that?
X equals
0.
0. X equals negative 1.
Good.
And x equals 1.
If you've got the roots, you've also got the whats? Solutions. And you've also got the x-intercepts. 0 function. You're good. True. Should have a dotted negative 1 come to 0, 0 come to 0, 1 come to 0. And yes, your graphing calculator can graph this. That being said, what kind of a cubic is this? Nate, help me out. Is it a positive or negative cubic? Positive. How do you know? Height multiplied is positive. So is it the left or the right? The left. Match this with this. It's going to come up, then down, then up. And it's going to be balanced. The reason I know it's balanced is because the same distance here, same distance here. I guarantee it's same distance here, same distance here. Okay? It should be balanced. It's symmetric over the origin at least. So question, does this thing, the reason we're playing with this is, does it have any maxes and mins? Nick, take over.
What was the question?
Any maxes and mins?
So
Categorize them.
there's going to be a local maximum
A local maximum, okay,
and then a local minimum.
correct. And then a local min. I'm going to ask a little more about that. Let me see. Becca, it's local max, but there are 2 other categories. Is this smooth or non-smooth?
Smooth.
It is smooth. How about the other one?
Smooth.
Also smooth. Let me see why. If you tap it with your hand, there's no blood. It's nice and rounded. Is it natural or artificial? Awesome. Natural. The only way you get an artificial one is if they chop it somewhere. So this is a natural, smooth, local max. This, natural or artificial? Also natural. This is a natural, local, smooth minimum. I wrote it backwards. So we're categorizing using the 4 categories. Okay? Now comes the fun part. I mean, that was fun, but where are they? Where is that local maximum? Where's that local minimum? Take whichever one you want first. And by the way, have your calculator handy. We're going to use it in a little bit. I will show you both the power of the calculator and the limits of the calculator. I need to grab my own calculator. But for right now, I want you to find the location of that without a calculator. Any ideas? Because I will tell you right now, algebra is largely helpless at this point. It cannot find the exact location of the x. Let's try the minimum. What value of x is the minimum? Again, algebra doesn't know what to do. It's not a vertex. I mean, sort of a vertex-ish. But we can't put this in vertex form. We don't know what it would be. Yeah? Ah, derivative. Welcome, calculus. What is the derivative of this thing? 3x squared minus 1. Excellent. Question. What use is the derivative? Nate, take over.
What use is the derivative? I'm not sure.
Okay. What does the derivative find? What is the derivative on a graph?
Oh, the tangent slope.
The tangent slope. I mean, that's good. And I'll write that down. This is the tangent slope. But what good is that? What does it do? What possible good would it be for us? If you can find, this tells you the slope at any given value of x. Like, by the way, if you took the values of x, like way over here, tell me, is the slope over here positive or negative? Joe? Positive. All the slopes are positive. Would the derivatives over here be positive or negative? Yeah, the derivatives are the slopes. So exactly. If you just take a look at the graph, everybody look up here for a second. On the left-hand side of the maximum, I guarantee you all the derivatives are positive. How do I know? Because all the slopes are positive. The slope, the tangent slope is the derivative. Once you get to the maximum, the slope is 0, which means the derivative is 0. Here, the derivative went negative for a while. And then the derivative goes to 0, and then the derivative starts going positive again. The tangent slope is the derivative. The derivative is the tangent slope. So whichever one is easiest to find, you can find it. Right here, I know that this formula is going to give me positives to the right of this. I have no idea where it is. And it's going to give me positives to the left of this. And it's going to give me negatives in between. But to find out where the max and min are, force it to be equal to 0. If you put this, you're basically saying, quote unquote, find all horizontal tangents. Why should we care about horizontal tangents? Because smooth maxes and mins will have horizontal tangents, and you'll be able to find them. Somebody solve this for me. Mary, take over. Just ignore this part.
So add 1 to both sides.
Good. So 3x squared equals 1. Keep going.
Then divide by 3.
Okay. X squared equals 1/3.
And then square root both sides.
How many answers?
2.
2. What kind?
Positive and negative.
Right. And you do not have to simplify this much. I would like you to do square root at the top, square root at the bottom. That's easy to do. You need not get the radical out of the basement. Why? Because we are strike force calculus and we are tough. But do remember, by the way, if a pre-calc person comes walking in and their eyes bug out, does it remember how to fix this just so they don't have a mental breakdown? Yeah. Yeah, so it'd be radical 3 over 3. So for the poor slobs who got, I mean, lovely souls who come walking in here from pre-calc, that's not, I'm just talking in general. Then you can fix that if you want. If some poor soul from Menards come, well, they wouldn't be worrying about this anyway. But you get the idea. In other words, if you can fix it for a non-calculus person, it's an act of charity. Now, tell me, this point here, you should be able to give me one of those two numbers. Which one? Okay. I want to know where this point is. Something comma something, and you should be able to tell me one of those numbers now.
X.
X. What is that? Now it's the one on the right-hand side.
So it's going to be negative 1 over, wait, positive.
Yeah, X is how far left or right it is. So if X is negative, it'll be over here.
Yeah,
So it's what?
positive 1 over radical 3.
Exactly. Are we okay? Now find the height. Sam, you're on. How do you find the height on this thing?
You put 1 over 3 in for x.
In for X. Everybody look up here. Here's a critical juncture. If you get over this hump, the rest is easy. If you trip over this hump, you'll be flat on your face. See, 1 over radical 3 is X. I want to find Y. You said plug that in. I agree wholeheartedly. Plug it in where? Because I see two different formulas. I see this one, and I see this one. Which one would give you Y? How come? Explain.
Well,
F of X is Y. What is this? Is this Y? Which is also what? It's Y prime. It's not Y. Very good. If you want the height, go to the original equation. That's height. If you plug it in this, it will not give you the height. It'll actually give you the slope at that point, which I think you'd get 0. Now the really fun begins. Go ahead and plug this in. So F of 1 over radical 3 is equal to 1 over radical 3 cubed minus 1 over radical 3. I never promised you a rose garden. So, try it. That was an old song way back then. Never mind. Somebody cube this for me. How do you cube a fraction? I think I heard it. How do you cube a fraction? Yeah.
Cube root.
Cube root is the backwards version. How do you cube a fraction? Yeah. Cube the top, cube the bottom. What's 1 cubed? 1. What's radical 3 cubed? Radical 3 times radical 3 times radical 3. That's adding. Let me write it out. Radical 3 times radical 3 times radical 3. There are 2 different answers for this. They're both right, but one's better than the other. What's that? How'd you get it? How'd you get it? Whoever did it. There are lots of people whispering to each other, so I don't know who is the originator, but go. It is 3. And by the way, that is a nice simplified one. So other people say this is radical 27, which is true. We have to reduce it by splitting the perfect square off, and you'll actually get back to 3 radical 3. Minus 1 over radical 3. Okay, people who've let their common denominator skills gather 20 feet of dust on them. Time to dust it off, vacuum it up, and do it. I want to subtract fractions. I need to find a what? Like what? How do you fix this one so that it works? What's it missing? Yeah, multiply by 3 over 3. So tell me what I get.
You're going to get 2.
Add the opposite. And so it's 1 over 3 radical 3 plus negative 3 over 3 radical 3. What do you get?
2 over 3 radical.
Sort of.
Negative.
Negative 2 over.
3 radical.
Congratulations, you just found the height. Can anybody find me the height of the other one? There are two ways to do this, actually. The normal way, and there's a sneaky way on this particular graph. Yeah. You want to take a wild guess? Let me put an arrow here. So this is negative 1 over radical 3, comma, something. Anyone want to take just a wild spinning guess?
2 over 3 radical 3.
Exactly. How do you get that so fast?
Just the opposite of the other one.
It's the mirror image of the other one. This particular graph is symmetric. It goes down the same amount as it goes up. So if it goes down, negative 2 over 3 radical 3, this is going to go up 2 over 3 radical 3. The technical way to do that is to plug in negative 1 over radical 3. You will get the answer of positive 2 over 3 radical 3. Everybody got the hang of that? Okay. Now, what happens if they're trying to get you, is everybody okay with this part? The non-smooth, blah, 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 blah. The last page has truncated problems. And by the way, you know yesterday, anybody who was here yesterday, we had a discussion of what's the derivative at an amputation? Like, could a derivative exist there? I did some thinking last night, I did some digging, and I found out that our answer was right. That the people who thought that there was a derivative there are pretty much guaranteed wrong. That there is no derivative when you amputate. I'll show you why in a minute. For right now, let's try this. G of x is equal to negative x squared plus 4, comma. Where x is restricted to the interval from negative 1 to 3. This is what we call a truncated function. In other words, it would have been an upside down parabola, you know, all of its full glory, but its two limbs got shot off, or hacked off. Take your favorite gross metaphor for it. Can anybody graph this thing for me? How would you graph negative x squared plus 4, just in general? What shape is it, first of all? Go. It's a parabola. Where's the vertex? Now, a normal graph of a parabola, if they don't mess with it, is 0, 0. Did they move this at all? Moves are addition and subtraction. Resizes are multiplication and division. Flips are change the sign. Everybody see one? Go. They moved to where? That would be input, though. That would be input. Go. 4 up. Correct. This is outside the square, so it's output, and it does what you expect, and output is up, down. So it's going to go up 4 spaces. And tell me, oh math people, is this going to go up or go down? Back up.
It's gonna go down.
Down. How do you know?
It's negative in front of that.
In front of what? Right. Height multiplier. What's the pattern?
So it's over 1, down 1.
Over 1, down 1. Do that, everybody, in your notes. Over 1, down 1. Keep going.
Over 2, down 4.
Over 2, down 4. Take a look at the truncation. How far do we have to go?
Negative 1 to 3.
Yeah, from negative 1 to 3. So go out to 3. Go one more jump, in other words. Over 3, down
Not negative
9. Yeah, so you're going to be way down. What's the height we're going to reach? We're at 4 to start with. If you go over 3, down 9, where are you going to end up?
negative 5.
Negative 5, yeah. So here's dots, dots, dots. Do me a favor, before you draw the parabola, hopefully you didn't draw the parabola yet. make it really, really, really light. Make it super duper duper ridiculously light. Now, can somebody darken in the part of the parabola that actually exists? Jill, come on. It exists from where to where? From x is negative 1 to x is 3. Can you find where x is negative 1? Yeah, everybody look up here. Please do not put any dot down here. Follow the graph until you hit x equals negative 1. That's right here. Do you want to include that point? Yes, because it's square. And then that'll be darkened all the way to what? 3 comma negative 5. Darken, 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 darken. Well, say that 3 times fast. It's hard. That's your graph. Okay, I didn't mean to let it over. That is your graph. Why did we have to draw that graph? Because I want the maxes and mins, and there are more than you might have expected. A downward parabola normally has one extremum. It's a maximum. It's still true, it does. But can somebody identify and categorize the maxes and mins? First of all, give me the location, and then tell me the 4 categories of what they are. Pick one. Mary, go for it. Pick your favorite extremum in here. Give me the coordinates.
0,
0, 4. Okay. Tell me about it.
It's the natural.
Natural, definitely.
Smooth.
Okay.
Global mix.
Smooth, global, maximum. That is excellent. Why is it natural?
Because if it was a regular parabola, that would be the highest point.
Right. That's the one that occurs naturally. If it were a regular parabola, that's exactly where its one and only extremum would be. Why is it smooth? The only way we know is a metaphor. If you touch it, you won't bleed. It's just bouncy, bouncy, bouncy. Let me see. Nick, take over. Why is it global?
Because it's the highest point on the graph.
Yeah, it's the highest point on the entire small graph. Why is it a maximum? This is a stupid question, but
It's the highest point.
yeah, it's a high point, not a low point. Now, take over. Pick another one. Give me the coordinates. What comma what? Oh, and I forgot to. This is 0, 4. Okay, what's the next one?
Negative, and 3 and negative 5.
3 comma negative 5? Okay. So 3 comma negative 5. Tell me about that.
It's artificial.
Artificial, good. Just a second. Artificial. I'm going to abbreviate. Okay.
And not smooth.
Non-smooth.
Global minimum.
Why do you say global? You're right, by the way.
It's the lowest point on the graph.
It's the lowest point on that small graph, ever. These parts don't exist. This does. So it's the lowest point ever. And global what? Minimum. Correct. Can somebody name any others? Blake, are there any other extrema in this whole thing? If so, where? Negative 1 comma what? 3. Good. Negative 1 comma 3. Tell me about it.
It's
Artificial.
non-smooth.
Non-smooth. Forgive me if I'm just abbreviating. Local. Minimum. Why is it local?
Because it's not the lowest point.
Right. It's the lowest point in the local area, but not overall. Excellent. Does everybody see these? All right. Look at your worksheets. Problems 4, 5, and 6 involve truncated problems. Number 4 is a, do we do part of number 4 or all of number 4? Okay. Number 4, my hint to you, factor it. You should be able to find the x-intercepts. Yeah. Oh, yeah. How many did we actually do? 1. Oh, we were going to do number 4, weren't we? All right. Fair's fair. Okay. I do want you to help step me through. Is everybody okay with this part? Speaking out for older people. Okay. Problem number 4 on the worksheet says y equals negative x to the 4th plus 3x squared plus 2. And it's restricted on the interval from -1 to 1. So it's truncated. First of all, can somebody tell me the basic shape of this graph? What degree is it? Sam, start up top. What degree is this thing? 4. What basic shape does a degree 4 graph have? This is a pre-calc question. Anybody remember at all? A parabola is degree 2, and it's just a U shape. A cubic is up, down, up. Yeah.
A W.
It's a W shape, or possibly an M shape. So, by the way, if it's degree 4, here's a quick way to find out what that looks like. Let's say, pretend something is degree 7. I can give you a quick, rough sketch of what that might look like. Let's say if it's positive degree 7, watch. Any idea where that came from? Yeah. It hits the x-axis 7 times. It has to swivel enough times to hit the x-axis 7 times. Now, it may not be that perfect. It could be like this. It might only hit the x-axis once. It tried, it just wimped out the other times. But it tried to hit the x-axis 7 times. This is a positive version. Anybody know what the negative version would look like? Josh, help me out. How many times should it try to hit the x-axis? 7. What would be the difference?
Oh, you start from above.
Yeah. Down, up, down, up, down, up, down. That's a negative degree 7. So if you want to try this trick, try degree 4. 1, 2, 3, 4. Or that's the positive version. Or the negative version is 1, 2, 3, 4. It looks like an M. Does that make sense? That's a really quickie way of finding one of these graph sketches. So I'm expecting an M shape because it's a negative degree 4. Can anybody find anything about this whatsoever? From the looks of it, you can probably find at least 2 things about it without any calculus. Think of how you would graph anything. What special points do you look for? I mean, vertices, yeah, but that's going to be calculus. What are the 2 most basic, nice points you look for? Yeah?
Because if it's negative or positive.
True, if it's negative or positive, then you can just use the table. What special points do you normally graph? Becca? Like if you're graphing a line, what 2 special points show up, usually? For example, here's a graph, here's a line. What are these? X and Y intercepts. Find them. Anybody? Moping it up to the floor. Not literally. You. How do you find the x-intercepts? In anything. Go. Or you were scratching your head. Go ahead.
Could you substitute x squared for x?
By the way, that's super clever, and yes, we're going to do that in a minute. But how do you find x-intercepts? What? Plug in 0 for what? If you want x-intercepts, you plug in 0 for y. If you want y-intercept, plug in 0 for x. Can somebody tell me the y-intercept? It's actually staring at you. 2. Plug in x equals 0. We know the y-intercept is 2. 0, 2. Question, is that going to be on our graph? Is that on the legal existing part of the graph? Yeah.
Oh wait, oh, never mind.
Yes, why do you say that?
Because it's in between.
The graph exists between x equals -1 and x equals +1. This is dead set in the middle. So yes, this is one of our points. All right, I like the idea of substituting u equals x squared. Can somebody plug that in? Actually, Nate, go ahead. Y equals what?
-u squared
Good.
plus
3u.
plus 2.
Is that factor?
Yes.
Do it.
Well, first we take out a negative.
Okay, pull out a negative. Let me make sure I copied this correctly. Is that -x to the 4th plus 3x squared? Yeah, plus 3. Okay, good. Go ahead.
So y equals -1 parentheses u squared minus 3b minus 2.
All right. Does that factor? Can you find two numbers that add up to -3 and multiply to be -2?
So it's going to be y equals -1, -2, -1.
There's only one catch. Multiply those. What would you get? What's -2 times -1? +2. Unfortunately, it doesn't work. So close. That was actually cruel. It was just like, I can just salivatingly taste it. It doesn't work. So, pre-calc has failed us. Let's see what calculus can do. Take the derivative. Y prime. By the way, that is the smart thing to have done. That's exactly what I would have done. I went that far and I literally crossed that off on my answer key. That's exactly what I did. That is a very smart thing to do. The fact that it failed is not your fault. It's this stupid thing, lovely thing's fault. Okay? Y prime. Josh, go. What's the derivative of this thing?
So the -4 x cubed.
Okay.
Plus 6x.
Okay, good. And Shaylee, what do we do with this? What possible use is the derivative? Set it equal to 0. Do it.
So be plus x or -x. Or
Actually, a little bit
2x,
bigger.
bigger.
Pull out a -2x, and what's left behind?
2x
Uh-huh.
squared plus, oh, minus 3.
Yeah, plus -3 equals 0. What does this give you? X equals what?
0.
0. Solve this one. So you had 2x squared minus 3 equals 0. Keep going.
So add 3 to sides.
Good. So 2x squared, I'll try not to make you talk too much. Sorry.
Divided by 2.
So x squared equals 3 over 2.
And then you square root, then you need 2 answers.
Yep. And I will actually let you leave it like that, because that really doesn't simplify much. We have two places where this thing is a max or min. Actually, 3. There's x equals 0, x equals radical 3 over 2, or radical 3 halves, I should say, and x equals negative radical 3 halves. Okay, math people, earn your keep. Which is which? We settled that it looks like this. And there are going to be 3 extrema. Which one is x equals 0, for example? Is it the one on the left, the one in the middle, or the one on the right? And by the way, I just slapped this up. It was just not supposed to be an accurate graph. Any guesses? Because I have 3 numbers here, this, and this, and they match up to these 3 extrema. Go.
Would be in the middle.
X equals 0 is in the middle. Prove it. How do you know it's in the middle?
So it's between,
How do you know it wasn't this one?
it's between the other 2.
Yeah, this is positive, this is negative, and this is 0 right in the middle. This, whatever happened, the graph looks like this. I guarantee you that's the middle point. If this is what we just did. All I knew is that it was going to be maxes and mins at these 3 locations. I now know something else. If you remember your pre-calc, that it's an M shape, I now know that this is a minimum at 0, 2. Austin, natural or artificial?
Would be natural.
Natural. Smooth or not smooth? Smooth. Local or global? As far as we know, it's local. Can somebody tell me what parts of this graph do not exist? Where does it stop existing? Go. Yeah. -1, +1. Tell me the heights there. At this point, grab your calculator. I'm going to show you one last little trick, and I'll hold this thing up to the screen. You may have discovered that one of the biggest pains in the neck is finding out the heights of these things. Finding the x value is not too hard. Plugging this in is annoying. Turn on your calculator. Clear off the main screen. Go to the y equals screen. Please type in the following. On the y1, clear out any equation you have. -x to the 4th, let me know if you need any help on this, plus 3x squared plus 2. Should look like this. People watching at home. If you didn't catch that, freeze frame and rewind. Hit enter. Now, go to zoom standard. See what this thing looks like. We got a pretty good prediction here. Now the question is, that's great, but can it give us any advice as to what the height is at x equals 1 and x equals -1? Maybe. Hit quit. Let me know what the quit key is. It's a little hard to see. Second mode. Mode is right next to the second key. That's actually one of the most important keys on here. If you're in the middle of something and it's running and you want to stop it, quit key is pretty good for that. Just hit quit and it'll go back to the main screen. Here's a trick. This is actually one of the reasons I like the graphing calculator the most. On your y equals screen, you have y1 is equal to -x to the power of 4. If you have a fancy calculator, it'll actually cram the exponent up there for you. Plus 3x squared plus 2. Everybody right so far? Now, quit out of that and go onto the main screen. Just gonna have this little, blinky, blinky, blinky thing. I'm about to direct you to one of the biggest, baddest, I know it's not a word, scariest menus in here. There's only one menu that's bigger than this. Can you look for a key that says VARS, short for variables? Yeah, I know it's VARS. Hit it. It's huge. Now here's what, hit the VARS key, it's right next to clear. Look at what you have. There's variables and y variables. Just look at the variables options. There's variables for the window, that's the graphing. You can actually manually change the window from here. There's zoom variables. There's GDB. I don't even know what that is, frankly. I've never used it. There's picture variables. That's if you're actually, there is a way to draw pictures on here if you really get into it. There's statistics variables, table values, string variables. Now, do you see on the top where it says y variables? Hit the right arrow and go over there. You should see 4 options. Function, for people looking at home, this is the variables key. And I just tipped over everything, sorry. The variables key is right by clear. It's right there. And if you hit it, it looks like this mess. So I want you to scoot over to the y equals screen, or the y variables using the right arrow. Ta-da. You should say function, parametric, polar, on, off. Ignore the last 3. You see where it says function? Hit enter. This is where you have like manual access to y1, y2, y3, y4, blah, 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 blah. Select y1 if you would. It probably is already selected. Hit enter. You should be back at the main screen. It should say Y1, blinky, blinky, blinky. Should look like that. This, do you remember you put formula into here? Here's what it looks like right now. Y1, blink, 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 blink. Do me a favor. Put a left parentheses. You remember what I said that whenever you want to plug something in, always use what? Parentheses. That's exactly what the calculator does. Do left parentheses just for fun. Type in the number 10 and close the right parentheses. Should look like that. Hit enter. What do you get? It's huge. Negative 9698. That means if you go over to 10, it's going to go down to negative 9698. You can find the height anywhere using that trick. Now, I want to show you one last trick. This is specific to the TI calculator. Have you ever been in a case where, I don't know how much you played with this. Shh, listen please, you're going to miss it. Have you ever been in a case where you typed a whole bunch of stuff and then you typoed? And they say, man, I wish I could do something without just copying it over again. Type, type, type over again. You can't. Hit the second key and hit enter. It'll call back what you typed before. But wait, there's more. Hit second enter again. And hit second enter again. Hit second enter again. It's going back in time to the last 20 things that you typed into the calculator. Okay? Now, some of it may be garbage. Some of it may be your little brother or sister playing with it. Oh well. Do me a favor. Math people, let's see who is paying attention. Look up here. Tell me how to get Y1 again. Hit clear, wipe it off. Tell me how to get Y1 again. Vars, variables. Go over to Y vars. Y variables. Then what? Function, and then Y1. Do parentheses. Guess what I want to test? What values of X am I curious about? Negative 1 and 1. Can't do them both at once, but type negative 1, close parentheses. Try it. Tell me what you get. What do you get? 4. So you get, oh, fluffernutters. Equals 4. And now, well, by the way, I did it earlier. If you plug positive 1 in, you also get 4. So you're going to get negative 1, sorry, positive 1. What am I doing? Comma 4 and 4. To be continued tomorrow. There is one more day without homework. Don't get used to it. By the way, here's what it looks like, y'all. And God bless your healing, everybody at home. See you later. Everybody please stand. And we'll do the prayer on the thing too. Might make you feel better. We'll be praying for y'all. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Practice your homework, if you will, is to play with this and see if you can get good at that. See if you can get good at entering values into Y1. You can enter anything, including radicals, fractions, etc. See y'all later. Bye-bye, y'all.